Okay, so the next question that we have here is, assume x, y, z, w, and p. X, y, z, w, and p are matrices of order, of order 2 by n and 3 by k and 2 by p and 3 by n, n by 3 and p by k respectively. Okay, now choose the correct answer in exercises 21 and 22. Now exercise 21, we have the restriction are on nk and p, the restriction on nk and p, so that py plus wy will be defined are, so we want to know the restrictions on nk and p, so that py plus wy is defined. So first of all, py plus wy is defined. If that is supposed to be the case, then of course py and wy must be matrices of the same order. Moreover, for py to be defined, then the number of columns of p, must be equal to the number of rows of y. So, and also for wy to be defined, the number of columns of w, w must be equal to the number of rows of y. Now this is number 1, this is number 2, and this is number 3. So we have to basically take into consideration all of these restrictions, and out of that calculate some numbers for the relative, basically for the variables that you have here related to, of course, py and w and y, right? Which means that the first one we said that py and wy must be matrices of the same order, meaning that basically the number of rows of p is supposed to be, the number of rows of py is supposed to be equal to the number of rows of wy, and the number of columns of py is supposed to be equal to the number of columns of wy. So I have to rewrite 1 as, or add to 1 as, now what I'm going to do is that I'm going to take the number of rows, for the sake of simplicity here, I'm going to take the number of rows as x, for example. Whenever I say x, that means the number of rows of something, and then we will refer to that. And the number of columns, I'm going to take it as y. So here basically the number of rows of py would be x of py must be equal to the number of rows of wy, x of wy, and also the number of columns of py, meaning y of py has to be equal to the y of wy. Now, what is the number of rows of py? When you multiply p and y, so you have basically p is a matrix of the order p by k, and y is a matrix of the order 3 by k. So this is p and this is y. So when you multiply these two, the number of rows and columns of the multiplication of the two matrices is going to be p and k, right? Which means that the number of which means that p becomes the number of rows of py and k becomes the number of columns of py. So the number of rows of py becomes lowercase p, and the number of columns of wy, we will see about that. Now the number of columns of py becomes therefore k, right? That is therefore k. So that these two we have already found out. Now wy, when you multiply w and y, w is a matrix of the order n by 3, and y is a matrix of the order 3 by k. Which means that the number of rows of wy would be n, and the number of columns of wy would be k, right? So here this gives me k is equal to k, which is, of course, I already knew that, which I don't have to worry about. But this means that p has to be equal to n. But this means that p, lowercase p, has to be equal to n. That is one condition that we have here. The second condition that we have is that for py to be defined, the number of columns of p must be equal to the number of rows of y. The number of columns of p is basically k. The number of columns of p is equal to k. The number of columns of p is equal to k. And that must be equal to the number of rows of y. The number of rows of y is 3. That is equal to 3. That means that k must be equal to 3. That is another condition. And so this is one condition, this is another condition. And also for wy to be defined, the number of columns of w is equal to 3. That has to be equal to the number of rows of y. The number of rows of y is equal to 3. Which is already the case, so I don't have to worry about this one. So the only two conditions that remain is that k has to be equal to 3 and p has to be equal to n. So that boils down to basically k is equal to 3 and P is equal to, and that is basically the conditions that we have here, which is choice A, I suppose. That is choice A in this question. Question number 1 would be question number 21. The answer is choice A. And let me actually, that is actually the correct answer. Now, the question number 22. Question number 22, we have having basically using the same matrices with the same properties and everything. If n is equal to p, this is lowercase p, then the order of the matrix, py plus wy will be defined are, no, if n is equal to p, then the order of the matrix 7x minus 5z is, okay, so now 7x minus 5z, the order of this matrix, so to figure out the order of this matrix 7x minus 5z, of course 7 is not important here, 5 is not important here. These are scalars and they are therefore not important in the order of the matrices, right? So x minus z is basically, if you take a look at basically the matrix X is a 2 by n matrix. X is a 2 by n matrix, and Z is a 2 by p matrix. Z is a 2 by p matrix. Now, if you suppose that you multiply a 7 by this matrix and multiply a 5 by this matrix and subtract this matrix from this matrix, therefore if you're allowed to do that, that means that n is equal to 2. That means that n is equal to 2, because otherwise that means that basically 2 is equal to 2 and n is equal to p, right? Because if you're supposed to be allowed to do this subtraction, the order of this matrix must be equal to the order of this matrix, meaning that 2 must be equal to 2 and n must be equal to p. And n is already equal to p. That means that the order of this matrix would be basically 2 by, you could say this 2 by n, or you could say 2 by p, because n and p are basically the same values. 2 by n or 2 by p, which is choice B basically over here is the correct answer, right? So that's basically all of the questions that we had here. And in the next video, we will talk about the transpose of a matrix. And so I'll see you in the next video, and thank you.